Are you working with exponents? Then you'll need to know these properties, so keep watching. Welcome to Math Bytes, I'm Allison, and today we're talking about properties of exponents. When you multiply a number by itself 2 or more times, you can indicate that multiplication with an exponent. So for example, 2 times 2 times 2 times 2 is equal to 2 to the power of 4. Now in this case, the base is 2, and the exponent is 4. There are some properties you can use when working with exponents, but let's go over a couple of definitions first. Here's our first definition. For any non-zero number b, b raised to the power of 0 is equal to 1. Now, 0 raised to the power of 0 is undefined, so that's one little caveat here. That's why b has to be non-zero. But 7 raised to the power of 0 is equal to 1. 1/2 raised to the power of 0 is equal to 1. Negative 4 raised to the power of 0 is equal to 1. But, this is tricky, the negative of 4 raised to the power of 0 is equal to negative 1. So be a little bit careful on things like that. Okay, here's another definition for you. If b is not equal to 0 and n is a natural number, so for example n is 1, 2, 3, etc., then b to the power of negative n is equal to 1 over b to the n. And 1 over b to the power of negative n is equal to b to the n. So when you move that negative exponent from the numerator to the denominator, or vice versa, the exponent becomes positive. Now, little caveat here, 0 to the power of negative n is undefined. So if we have 2 to the power of negative 3, that's equal to 1 over 2 to the power of 3. Or for example, 1 over 5 to the power of negative 2 is equal to 5 squared. So you see, as we move that negative exponent from the numerator to the denominator, or vice versa, the exponent will become positive. One more thing to keep in mind. Any number raised to the power of 1 is equal to that number itself. So for example, 6 to the power of 1 is equal to 6. Negative 4 to the power of 1 is equal to negative 4. A to the power of 1 is equal to a. So we don't always write that exponent 1, but it's there, just in case we need it. Okay, now that we have our definitions out of the way, let's look at some properties of exponents. For these properties, it is important to note that m, n, and p are integers, and a and b are real numbers. So here's our first property. b to the power of m times b to the power of n is equal to b to the power of m plus n. We can add the exponents up in this case. Now note the base is the same. b, the base, the number we're raising to the power, is the same. So we can add up those exponents. So for example, 3 to the power of 2 times 3 to the power of 7 is equal to 3 to the power of 2 plus 7, or 3 to the power of 9. a to the power of 6 times a is equal to a to the power of 6 times a to the power of 1. That's the same as a to the power of 6 plus 1, or a to the power of 7. If we have x squared y to the 4th times x cubed y to the 5th, we can add the exponents for the terms that have the same bases. So we get x to the power of 2 plus 3 and y to the power of 4 plus 5. Which is equal to x to the power of 5, y to the power of 9. Okay, here's another property for you. b to the power of m divided by b to the power of n is equal to b to the power of m minus n. Now we subtract the exponents since we're dividing. And in this case, b is not equal to 0 because we don't want a 0 in our denominator. So for example, 3 to the power of 7 over 3 to the power of 2 is equal to 3 to the power of 7 minus 2, or 3 to the power of 5. a to the power of 9 over a to the power of 3 is equal to a to the power of 9 minus 3, or a to the power of 6. If we have 2x cubed y to the 4th over x squared y, that gives us 2 times x to the power of 3 minus 2 times y to the power of 4 minus 1, or 2xy cubed. So when we're dividing, we can subtract those exponents. This next property involves raising exponents to other powers. So for example, b to the power of m raised to the power of n is equal to b to the power of m times n. If I have a to the power of m, b to the power of n, and I raise that quantity to the power of p, that's equal to a to the power of m times p and b to the power of n times p. If I have a to the power of m over b to the power of n, and I raise that to the power of p, that gives me a to the power of m times p over b to the power of n times p. And of course, in this case, b is not equal to 0. Okay, let's look at some examples that will be a lot clearer when we do that. What if we have 7 to the power of 2 raised to the power of 5? That's equal to 7 to the power of 2 times 5, or 7 to the power of 10. Okay, what about ab squared, and that whole quantity is raised to the power of 3? That gives me a to the power of 1 times 3 and b to the power of 2 times 3. So that gives me a cubed times b to the 6th. Okay, how about x to the power of 7 over y to the power of 9, and that whole quantity is squared? That gives me x to the power of 7 times 2 over y to the power of 9 times 2, which gives me x to the power of 14 over y to the power of 18. Now, when working with these properties of exponents, it's important to note that with expressions like these, there is no simplifying to be done, because in these expressions we have different bases. For example, in our first expression, the bases are 3 and 2. In the next expression, the bases are x and y. In the third expression, the bases are a and b. Our properties of exponents apply when the bases are the same. So in this case, you can't write these any simpler than they are. So don't make that mistake when working with these properties. Get comfortable with these properties, and you'll find working with exponential expressions much, much easier. That's it for this episode of Math Bytes. If you like our videos, please subscribe to our channel. And if you have a question for us, just send us an email. We're at contactmathbytes@gmail.com, and we'll see you next time.